Human-AI partnerships on the Jagged frontier, managing verification in the era of advanced AI. Abstract, the rapid advancement of large language models, LLMs, and AI agents is transforming human-AI collaboration from co-intelligence partnerships to interactions more akin to verification of autonomous outputs. This article examines the emerging wizard paradigm, wherein AI systems produce sophisticated outputs with minimal human guidance during the creation process. Drawing on empirical research and organizational case studies, we analyze the verification challenges that arise when AI capabilities simultaneously become more powerful and more opaque. The paper identifies three key verification domains: factual accuracy, process transparency, and contextual appropriateness, and presents evidence-based organizational responses for managing AI verification across different scenarios. As organizations increasingly deploy advanced AI, developing systematic verification strategies and cultivating appropriate trust calibration will be essential for capturing value while mitigating risks associated with undetected errors or misaligned outputs. Organizations are rapidly deploying increasingly sophisticated AI systems that can generate complex outputs with minimal human guidance. Recent advances in large language models, LLMs, have created a fundamental shift in how humans interact with AI, from collaborative partners who guide the AI through iterative feedback to verifiers who evaluate AI's autonomously created outputs. Bender et al. 2021. This transition from the co-intelligence paradigm to what Etzioni, 2023, calls the wizard paradigm presents profound challenges for organizations seeking to leverage AI's capabilities while maintaining appropriate quality control. The stakes of this shift are significant. When verification fails, organizations risk propagating errors, making decisions based on flawed analysis, or publishing content that damages reputation. Conversely, excessive verification can negate AI's efficiency benefits and hinder innovation. As AI capabilities expand across the jagged frontier of task performance, Brynjolfsson et al. 2023, organizations must develop new verification strategies that balance trust with scrutiny across different contexts. This article examines the emerging verification challenges in human-AI partnerships, synthesizes evidence on effective verification approaches, and offers a framework for developing organizational verification capabilities that evolve alongside AI advancement. The AI verification landscape. Defining verification in human-AI partnerships. AI verification refers to the process by which humans assess the quality, accuracy, and appropriateness of AI-generated outputs. Verification differs from validation, determining if the AI system meets intended requirements, and focuses specifically on evaluating individual outputs rather than the system as a whole. Jagged et al. 2022. The verification process becomes especially challenging as AI outputs grow more sophisticated and the gap between output complexity and human oversight capabilities widens. Schneiderman, 2022, distinguishes between human-centered AI, where humans maintain significant control throughout the generation process, and AI-centered automation, where systems operate with high autonomy. Today's advanced LLMs increasingly represent the latter, producing complex analyses, multimedia content, and data transformations with minimal human guidance. This autonomy necessitates robust verification approaches that can detect errors or misalignments without requiring deep understanding of the AI's internal processes. State of practice: from co-intelligence to wizard verification. Recent surveys indicate organizations are increasingly confronting verification challenges. In a 2023 survey of 1,200 enterprise AI adopters, 76% reported implementing some form of human review for AI outputs. But 64% acknowledged that comprehensive verification was impossible for complex AI-generated analyses. Stanford HAI. 2023. Similarly, Kasparov and Harolds, 2023, found that 71% of knowledge workers reported shifting from collaborative AI interactions to verification-focused workflows as AI capabilities advanced. Verification practices vary considerably by domain and risk profile. In high-stakes areas like healthcare and finance, organizations typically implement multi-layered verification protocols, while marketing and content creation often employ lighter-touch approaches. Kaplan et al. 2023. However, as Mohini et al. 2021, note, verification protocols have not kept pace with AI capabilities, creating a growing verification gap in many organizations. Organizational and individual consequences of verification challenges. Organizational performance impacts. The verification gap has measurable consequences for organizational performance. In a study of 142 organizations using advanced LLMs, Brynjolfsson and Jin, 2023, found that inadequate verification protocols were associated with a 12% increase in consequential errors and a 23% reduction in realized productivity gains from AI adoption. Organizations with formalized verification processes captured 31% more value from their AI investments compared to those with ad hoc approaches. The economic impact of verification challenges manifests in several ways. First, direct costs emerge from undetected errors. Microsoft's early deployment of its Bing chat system reportedly cost the company over $9 million in emergency corrections and reputation management when inadequate verification allowed factually incorrect outputs to reach users. Vincent, 2023. Second, organizations incur opportunity costs when excessive verification reduces RE's efficiency benefits. Accenture, 2023, estimates that inefficient verification processes reduce potential productivity gains from generative AI by 30 to 45%. Beyond direct financial impacts, verification challenges affect strategic outcomes. Organizations struggling with verification report lower innovation rates, 14% below average, and slower AI deployment, potentially ceding competitive advantage. Brynjolfsson and Jin, 2023. Meanwhile, those with mature verification capabilities report higher user trust and adoption, creating a verification advantage that accelerates AI value realization. Individual well-being and stakeholder impacts for knowledge workers. The shift to verification-focused work has mixed implications. On one hand, AI can automate routine tasks, potentially creating more meaningful work. On the other hand, the responsibility of verifying increasingly sophisticated outputs creates new cognitive burdens and potential skill atrophy. A longitudinal study of knowledge workers at Boston Consulting Group found that shifting to verification-focused workflows initially increased reported job satisfaction by 31%. But these gains decreased to 12% after 6 months as verification fatigue emerged. Brynjolfsson et al. 2023. Similar patterns appear in editorial, legal, and creative professions, where workers report verification anxiety stemming from responsibility for errors they may lack the capability to detect. For end users and customers, the consequences of verification failures can be significant. The CIID survey of 5,000 consumers found that 67% had encountered factual errors in AI-generated content, and 43% reported making consequential decisions based on incorrect AI outputs. Kozakov, 2023. These experiences correlate with declining trust in organizations that deploy AI without adequate verification safeguards. Evidence-based organizational responses. Tiered verification frameworks. Organizations successfully managing verification challenges typically implement risk-stratified approaches that allocate verification resources based on potential impact. Evidence suggests these tiered frameworks significantly reduce errors while maintaining RE's efficiency benefits. A structured analysis of verification practices across 57 organizations by Lee and Jinasaw, 2022, identified 3 effective tiered verification models: consequence-based verification, Calibrating verification intensity to potential harm. Confidence-based verification, focusing scrutiny on outputs where AI expresses low confidence. Domain novelty verification, applying higher verification standards to outputs in new or changing domains. Effective approaches to tiered verification, developing clear taxonomies of output risk levels with corresponding verification requirements. Implementing automated verification triggers based on confidence scores. Novelty detection and impact assessment, creating streamlined escalation paths for outputs requiring deeper verification. Establishing verification SLAs that balance thoroughness with efficiency. Google's content moderation team restructured their verification workflows around a 4-tier model that classifies AI outputs by potential harm and applies corresponding verification protocols. This reduced harmful outputs by 73% while actually increasing overall content throughput by 14% through more efficient allocation of human verification resources. Lee and Ginesar. 2022. Collaborative verification networks. Organizations are increasingly moving beyond individual verification to collaborative networks that distribute verification responsibilities across multiple stakeholders with complementary expertise. Effective approaches to collaborative verification, creating cross-functional verification teams that combine domain expertise with AI literacy. Implementing verification circles, where outputs are reviewed from multiple perspectives. Establishing verification documentation standards that support cumulative review. Developing verification bounty programs to incentivize identification of subtle errors. Atlassian developed a verification mesh approach for their AI-augmented software documentation system. Rather than relying on individual technical writers to verify all aspects of AI-generated documentation, they implemented a distributed verification protocol where developers verify technical accuracy, technical writers verify clarity and style, and end users verify usefulness. This collaborative approach reduced verification time by 41% while increasing error detection by 27% compared to their previous centralized verification process. Komath and Singh. 2023. Augmented verification tools. As AI outputs become more complex, organizations are developing specialized tools that augment human verification capabilities, essentially using AI to verify AI. Effective approaches to augmented verification, implementing automated fact-checking systems that validate claims against trusted sources. Deploying model disagreement detection to flag outputs where different AI systems produce contradictory results. Using automated explanation generators that make AI reasoning more transparent. Creating verification-specific LLM prompting techniques that optimize for error detection. The Associated Press developed an AI verification toolkit for their journalists that combines multiple verification techniques, including automated source verification, contradiction detection, and uncertainty highlighting. When analyzing complex AI-generated research summaries, journalists using the toolkit identified 34% more factual errors while reducing verification time by 23% compared to unaided verification. Roberts. 2023. Verification training and capability building. Organizations are investing in specialized training programs to build verification-specific skills that differ from traditional domain expertise or general AI literacy. Effective approaches to verification training. Developing verification-specific competency models that identify key capabilities. Creating simulation environments where employees practice verification with artificially injected errors. Implementing verification certification programs for high-stakes domains. Establishing communities of practice focused on verification techniques and lessons learned. Goldman Sachs created a dedicated AI Verification Academy for their investment banking analysts who review AI-generated financial analyses. The program focuses on specific verification techniques like strategic sampling, anomaly recognition, and counterfactual testing. Analysts who completed the program identified 43% more errors in complex financial models and reported 31% higher confidence in their verification judgments. McKinsey. 2023. Building long-term verification capabilities. Verification-aware AI design rather than treating verification as purely a post-generation concern. Leading organizations are working with AI developers to create systems that facilitate verification throughout the generation process. This approach involves designing AI systems that explicitly support verification by providing appropriate transparency, confidence indicators, and supporting evidence. Schneiderman, 2022, argues that effective verification-aware AI design allows humans to look under the hood of AI outputs without requiring deep technical understanding of the underlying mechanisms. Key elements of verification-aware AI design include explicit sourcing for factual claims, confidence indicators calibrated to actual accuracy, and documentation of key decision points in the generation process. Organizations like OpenAI and Anthropic have begun incorporating these features, though significant gaps remain between theoretical ideals and practical implementations. Bomasani et al. 2022. In practice, organizations can influence verification-aware design through specific procurement requirements, collaboration with AI providers, and creating market demand for verifiable AI. The Financial Services Consortium FINRA has developed verification-focused procurement standards that its member organizations use when selecting AI vendors, driving industry-wide improvements in verification capabilities. FINRA 2023. Verification governance structures. As verification becomes a critical organizational capability, leading organizations are establishing formal governance structures to oversee verification activities and continuously improve verification processes. Effective verification governance typically includes clear roles and responsibilities, verification quality metrics, incident response protocols for verification failures, and regular verification process reviews. Kozakov, 2023. These structures help organizations transition from ad hoc verification to systematic approaches that evolve alongside AI capabilities. IBM's AI Verification Governance Framework embeds verification responsibility at multiple organizational levels, from individual practitioners to executive oversight. The framework includes quarterly verification quality reviews, a dedicated verification incident response team, and verification performance metrics linked to performance evaluations. This structured approach has reduced critical verification failures by 58% while simultaneously decreasing verification costs by 27% through continuous improvement. IBM 2023. Adaptive verification calibration. Perhaps the most challenging aspect of verification is determining the appropriate level of scrutiny for different AI outputs. Too much verification negates AI's efficiency benefits. Too little risks errors and harms. Leading organizations are developing adaptive verification calibration approaches that continuously adjust verification intensity based on empirical performance data rather than static assumptions. These approaches track verification results over time to identify patterns in where errors occur and update verification protocols accordingly. Mayo Clinic's radiology department implemented an adaptive verification system for their AI-assisted diagnosis workflow. The system initially required high verification for all AI analyses but gradually reduced verification requirements in areas where AI consistently demonstrated high accuracy while maintaining stringent verification in areas with higher error rates. This approach reduced overall verification time by 41% while maintaining diagnostic accuracy rates equivalent to full verification. Mayo Clinic 2023. Conclusion. As AI capabilities advance across the jagged frontier, organizations face a fundamental shift in how humans interact with AI, from collaborative partners to verifiers of increasingly autonomous outputs. This transition creates significant challenges but also opportunities for organizations that develop sophisticated verification capabilities. The evidence suggests that effective verification requires a multifaceted approach combining tiered frameworks, collaborative networks, augmented tools, and verification-specific training. Organizations that treat verification as a strategic capability rather than a tactical necessity are better positioned to capture AI's benefits while mitigating its risks. Looking ahead, verification will likely remain a moving target as AI capabilities continue to evolve. The organizations that succeed will be those that build adaptive verification systems that can evolve alongside AI advancement, rather than static approaches that quickly become obsolete. By investing in verification-aware AI design, formal verification governance, and adaptive calibration, organizations can navigate the wizard era while maintaining appropriate human oversight of increasingly magical AI capabilities.